So in this video, we're going to be talking about how a dendrite grows. And we're going to remember that in our central nervous system, dendrites just don't grow like brand new dendrites. Instead, we're going to talk about the dendrite being like a branch on a tree. So the tree is the neuron and the dendrite is a branch. Now you could have an underutilized or a sickly neuron or a sickly tree that only has a few branches on it. But ideally we want a living, breathing forest that is our brain. So we want really dense networks of dendrites and dense canopy of a forest. So as we see this growth patterning happening, we're going to instead think about it that a dendrite or a branch is splitting, and that's increasing the density of the dendrites in this area. So just like a forest would grow and a tree would grow in the forest and increase the density of its branches so that it captures all the sunlight coming down, the same thing with our dendrites. We're going to get very dense networks of dendrites in the areas of our brain that we utilize the most intensely. So whenever we talk about a dendrite splitting or growing, or this is what we're going to call long-term potentiation, we always start with new information coming in. So for this example, we're learning how to walk on ice. And I grew up in Wisconsin, and so I had to learn how to do this really quick. I still can remember the first time that I had not learned this skill. I ended up with a nice bruise. So this is going to be an essential skill for someone who lives up north. We need to be able to learn to walk on ice. Now this is a new skill because it's different than walking on non-ice surfaces, on typical ground. So new information is going to come in about how walking on ice feels and the need to walk on ice, and that's going to start this process. So as this new information comes in, we see that glutamate is going to be released from a neuron into an area where we are going to learn how to walk on ice. So you see this glutamate's coming in. Okay. Now, the receiving neuron has a bunch of ligand gates with receptors called NMDA receptors. And these receptors become activated with glutamate. So on the receiving neuron, there are inactive NMDA receptors that when the glutamate comes in, we're going to see that it activates these receptors. Now, once that glutamate triggers the NMDA activation, we're going to see a release or an allowing of an increased amount of calcium into the cell. So once that NMDA is activated, it's going to allow more calcium into the cell. And calcium is good for us because calcium triggers this substance in orange called AMPA. So you can see it's triggering AMPA, and AMPA gates are activating. We also see from deep within the cell, we're going to have more AMPA migrate towards the membrane of the cell. So not only were the receptors on the cell membrane right here becoming active, but from deep within the cell, we're going to get more AMPA migrating to the surface of the cell membrane or the surface of the dendrite. And this causes the start of the splitting of the dendrite into two different dendritic formations. So we've just now split our branch into two dendrites. Now we have two dendrites instead of just one. So we have two places in our brain to activate and to work on helping us control our gait pattern when walking on ice. And over time, these are going to get stronger and these are going to split. And this one is going to split. And it'll keep splitting and keep splitting until we have this dense canopy of dendrites for learning how to walk on ice and for being able to walk on ice. Now, the important thing to remember is, so now I learned how to walk on ice, and that was wonderful and everything, but I moved down to Arizona. And in Arizona, as many of you know, we don't need to walk on ice so much. It's not an essential skill. So these dendrites over time are not going to be utilized anymore because I don't need that skill. Do they die? No. But do they become inactive? Yes. So if I were to go back up north and decide to move back to Wisconsin, you would see that in the beginning, I would have trouble activating all these dendrites again. Now I would learn the activity or remember the activity much quicker. But if you don't use these dendrites, you will lose them and they will atrophy just like a tree would atrophy and shrivel up or maybe lose some of its branches over time. So if you don't use it, you lose it. Actually applies a little bit to our dendritic situation. Okay, I think that's all for now.